Oh, hey everybody, come on in. Come on in. I didn't realize you were going to get here so soon. What am I building? Big seats. Well, you know what I'm building. I'm building a classroom full of scientists. Yeah, I know that's hokey. I always say that. My raw materials are the class of 2015. That's right. No, really, I'm building I'm cutting a piece of wood that I'm going to use a router on. And I'm going to make a little plaque for the front of my house. And it'll have my numbers of my house on it, so the UPS guy can find my home. But really, I brought you out here because what do we always say about science? Science is built. Science is constructed. And we take little pieces of information and we piece them together into a larger understanding. And then what do we use it for, Thomas? Exactly. We get some information, we put it together into a larger understanding, and then we use it to solve problems and make bigger understandings. And it's all just a great big building process. And that's why I bring you here, because I have a lot of things out here that I don't necessarily have in the classroom. So I brought you out here to show you something that I have that I think is going to be kind of cool to talk about. I want to get a little bit in my hand here and ask Amy. Amy, what is this right here? Dirt? Kind of like dirt. It's dark because it's a little bit wet, but okay, if it was a little bit drier, it would be a lighter color, and you might find it, say, underneath the swings of the playground. Sand, that's right. And this is sand. It's dark because I just dug it out of the ground out by my horseshoe pit. And the horseshoe pit that doesn't get much use, and that's why I had to dig through a little bit of grass in my horseshoe pit. So it's a little bit wet, but it is sand. And the reason that I wanted to use this sand was to see if anybody could guess the number of grains of sand that are in my hand right now. You don't know? I don't know either. And it's almost scary to think how many grains of sand there are. What's that, Betsy? Why would we care? Well, you'll see in a minute, I hope. But there's a way that we can figure out the number of grains of sand. In fact, at the University of Hawaii, they actually, for some reason, ventured into that endeavor. And probably because they live on an island, or several islands, surrounded by sand. And it's kind of a fascinating question. How many grains of sand are there? There are so many grains of sand that you would not even believe it. We have to come up with some creative tools to figure it out. So they started out with a spoonful, and they put it underneath a microscope, and they counted the number of grains of sand under the microscope. And then they were able to take that known quantity and expand it out to figure out how many spoonfuls there are in larger quantities of sand. Now, let me ask you, if we were to go buy sand, we could buy it by the bag maybe at Lowe's or Home Depot. Or we could buy it at a gravel pit. Does anybody know how you buy it at a gravel pit? Okay. Tim, your dad just bought some sand? What's he going to use the sand for? Oh, your younger siblings are getting a little playground that you never had when you were a little kid. But well, that's cool. At least they get the good deals. So he's building a playground. He's going to put some sand underneath, like the swing, the slide, and all that. And how did he buy it? He bought it by the cubic yard. That's right. And they call it a yard at the gravel pit, but they really mean a cubic yard. So how big's a cubic yard? Logan? Yeah, it's about like this, like this. Then what's the other part? There's a cubic. It's three-dimensional, so it's a cube. It's like a Rubik's Cube, except really big. Okay. So you got this cubic yard of sand that they scoop up and they put it into a truck or something like that. And there's a lot of spoonfuls in there. So when we buy sand, we buy it in some kind of volume measurement. We don't count grains of sand. Can you imagine if we went to a gravel pit and said, could you give me, and then you give them a humongous number and they have to count out the grains of sand? I think that would be a little bit impractical. So these University of Hawaii scientists started out with spoonfuls, made some assumptions, figured out that there are actually 10 to the 20th power grains of sand in all the earth. And if you think about all the sand that's in the earth, all the beaches, all the sand underneath the ocean, the sand around the Great Lakes, the sand that's in gravel pits all over the world, that's been deposited by ancient oceans, sand layers that are underneath the earth, all that sand was counted. And not inventoried like you would count in the back of a store, but basically accounted for through some assumptions. And they came up with that number, 10 to the 20th. I know, Beth, your brain hurts. Okay, give your gray matter a rest for just a couple of minutes. Okay, there's a reason that we're doing this. Now, what if we were trying to count something that we can't touch and feel and see, like sand? Let's see, how about if you were to go out into your backyard on a very dark night, look up in the sky, how many stars do you think you'd see? Eddie? 500? Yeah, maybe. It's probably a pretty good number. Okay. Cynthia, do you think he's high or low? You think he's high in the number of stars you could see. Now, let's say I was to ask the question, how many stars are there everywhere in the universe? Cynthia, what do you say then? You think he's low? Okay. I think you're right. Except I bet that you don't know how low he is. He's really low. Okay. So let's say that we were to endeavor to count the stars in the sky, the stars in our universe. We could build that knowledge bit by bit, piece by piece, kind of like I'm building the number plaque that's going to go on the front of my house, and like we're building knowledge as young scientists in earth science. So we would start with something that we know. So we've had telescopes for a long time looking into the universe, and we can see our galaxy fairly well, and we estimate that there are, and now we're going to use these exponents again. Remember, they are ways of expressing very large numbers. We have estimated that there are 10 to the 12th, that's a big number, 10 to the 12th stars in just our galaxy. What's our galaxy called? Jimmy? It's called the Milky Way. Yeah, you know why it's called the Milky Way? Because it looks milky or whatever? That's true. And that's exactly true. In fact, here's a little frisbee here, and it's shaped like a disc, and it looks kind of like the Milky Way is shaped, except the Milky Way is made out of stars, and we're sitting way out here on the edge of the disc. And when we look at the Milky Way, we're looking through the disc, and we see all those 10 to the 12th stars that are out there. And there's so many stars that it just appears to blend together into a milky appearance. So the question is our Milky Way representative of other galaxies? And scientists have determined that while there are different shapes and sizes of galaxies, the Milky Way is probably pretty close to right in the center of those. Okay, so 10 to the 12th is about the number of stars that we have out there. Now, how would we go about figuring out the number of galaxies like the Milky Way that exist in our universe? Ernest? Yeah, we would look through a telescope. Okay, but the problem is most of our telescopes are not that capable. Now, you know, they can see some of the galaxies, but we have a really cool tool. I know that rhymes. And it's a telescope in a very special place. It's not on a mountaintop. It's actually in orbit. Now, does anybody know what is really great about being in orbit if you're a telescope? Steph? Yeah, because you don't have to look through the atmosphere. When you're outside the atmosphere, all you're looking through is a vacuum of space, and it's a much clearer look, which means you can look further. And this telescope, and the use of this telescope by scientists has enabled us to gain understandings that we didn't really have before. Now, scientists have been able to determine, using this telescope, which is called the Hubble, after Edwin Hubble, a famous astronomer, they've been able to estimate that there are 10 to the 10th galaxies out in the universe. 10 to the 10th. We just said that there was 10 to the 12th stars in the average galaxy, kind of like our Milky Way. There's 10 to the 10th galaxies. So who can tell me what you do to multiply 10 to the 10th times 10 to the 12th to figure out how many stars there are? Beth? Exactly. You add the exponents. Remember that from math? So you get 10 to the 10th times 10 to the 12th. That equals 10 to the 22nd. And that's, interestingly, how many stars are estimated to be in our known universe. 10 to the 22nd. Okay, so time out for just a second. Let's go back to the sand, okay? How many grains of sand did we estimate are actually on the face of the earth? So 10 to the 20th. Okay, so we've got 10 to the 22nd stars in the universe and 10 to the 20th grains of sand in all of Earth, under the oceans, on the beaches, under the ground, every place. That means that there's more stars than there are grains of sand on the Earth. How many more? Well, 10 to the 22nd to 10 to the 20th means that there's 2 more digits. Each digit represents a power of 10. So 2 represents 10 times 10, or 100. So for every grain of sand on all the Earth, there are 100 stars in our known universe. Makes you think twice about whether or not there's actually life on a planet someplace circling one of those stars. There are so many of them that the possibility has just gone up, it seems. So we're going to be studying astronomy over the next several weeks, and we're going to start out at the far reaches of the universe, and then we're going to study right on into Earth and the Moon. And this is really going to be a lot of fun. And now you know approximately how many stars there are out there that we're going to be talking about when we talk about our galaxies and what makes up our known universe.